Try first. Don't just say, I can't. Try and find a way to do it.
We will exceed your expectations.
Nice to meet you. We are OMRON.
Welcome to the OMRON booth here at SMT Connect. I'm joined by Kevin Youngs, who's the European Sales Manager for Inspection Systems. Welcome,
Hello,
Kevin.
Yeah, thank you very much, Trevor.
Okay.
Thank you for a booth.
So, we've been having a long chat, and a very interesting one, about the approach to inspection. The goal for inspection companies everywhere is really to get zero defects going forward. What is the OMRON approach to this?
Okay, so Trevor, as you know, we discussed, OMRON is a manufacturer, SMT manufacturer as well, so we have our own processes. So firstly, we understand process. This is a key factor. Our products that we developed are for our processes, but for the benefit of other companies' processes. So this is what we develop for, and a strange saying, I think, that our philosophy is to develop for the benefit of society. So we are, in fact, an innovation company. So what does that mean? It means that we're looking for the future to develop processes, whether it is in the electronic industry or whether it is in food and beverage. Processes in general, OMRON are involved with. So we can take our own experiences and really forecast what the future may bring in terms of manufacturing. And that, with the level or the position we are now, is in a philosophy to develop zero defect processes. So what does that mean? In terms of electronic manufacturing, that can mean SPI, AOI, AXI. But also we manufacture beyond as well. As we've got the new 2D inspection system, actually, or metrology type system here, using 2D technology. I know this is not the buzzword in the industry at the moment, it's all 3D. But it is really a measurement machine as well as a inspection machine. So we are thinking zero defect beyond the SMT line, and the VT-M121 is a part of that philosophy. Of course, with OMRON we have robot as well. So in terms of automation, we have the capability to automate lines with robotic, whether it is fixed robot, cobot, or even the auto cobot, robot. So these are all technologies and principles that we have that now we bring and develop for the electronics industry. So yeah, these are all processes, and of course with the automotive industry now, working really fast with ADAS type products now, so the autonomous drive of the cars to make them autonomous. So the interaction between technology and the human is progressing. That means that manufacturing processes now are becoming much more more precise, which means that you need more precise tools to measure and also understand process. So from a measurement point of view, of course, OMRON has always been synonymous with high quality solder joint inspection. So whether that comes from our SGI technology, which is color highlight technology, integrating with phase shift technology to give real, or let's say 3D measurement of the solder meniscus as well as the component. Moving on to X-ray, where we have X750 now, which is a high-speed CT inline inspection system to find the difficult defects that other X-ray technologies cannot do. So this is the first core for OMRON, high-quality solder joint inspection and inspection systems.
And you can overlay the AOI over the SPI and the X-ray to look down at a particular defect.
Absolutely. So to expand the philosophy of zero defect, of course we take data, we can analyze data for different parts of the process. But beyond that now, OMRON release a new software, a new software which is called QUp Auto. QUp Auto now is not just looking at the inspection data, but also taking manufacturing data. So at the first stage, we collaborate with SMT placement machine, and even from post-reflow now, we can find defects from the placement machine, which is located from the nozzle, the head, and the reel. So This is the first stage of really having a higher understanding of the defects within the process line. So that means we are taking data from the placement machine to a core database with the software engine running behind that starts to integrate AI philosophy and control to be able to analyze with the inspection system the real trend of the production from the placement machine and from the oven based on the placement data and the inspection data.
Right, so you're actually now starting to take some profiling data from the oven and integrating it with the inspection data from further up the line to further refine the process.
This is the next stage, stage this year. So first we qualify the data from the placement, next stage is move on to the reflow oven, for sure.
I assume you're already taking it from the printer with the SPI and the printers.
That will be the next stage, of course, stage by stage, analysing, tuning, affecting the process, and then we can move to the next stage. So our goal, our target, which is our core strategy, is to have a process improvement tool that is IA-based, taking manufacturing data, combining it with inspection data, and giving real intelligent information to the process engineer or the process management to be able to improve their process.
So in some cases, is that going to be residing in the factory, that data, or and in some cases it's going to be in the cloud? Where is it going to? How is that going to work?
Step by step.
Yeah.
And we have the cloud technology, so in theory we can do this, but of course it's down to the customer.
Yeah.
Step by step how far he wants to progress.
Right. But the more data you collect, obviously, in the cloud and be able to analyse, the more intelligent your system's going to become.
Yeah. Well, the secret is having the right data, of course. Many systems can take data, and then the customer is overwhelmed with big data. This is the buzzwords now. But it's really understanding what to do with the data, but really understanding what in his process he really needs to affect with that data. Cure Porto is helping with that because of OMRON's experience of manufacturing. So we have proof of concepts in our own factories, working, developing these processes, tuning these processes. So in the real world with the customer, it is a real benefit, software ready to run.
You've done all the beta testing in your own sites. You've got it working like clockwork before you take it to the market.
Yeah, and continually developing as well, step-by-step tuning, improving, and then bringing those benefits to the customer, to the industry, I should say.
So, taking it now one step beyond the production line, we've got our 2D machine sitting behind us, and just very quickly before we go on to it, I would qualify that 2D is by no means dead. It's an essential part of the process.
Still with us.
Absolutely. I mean, you need to be able to read your barcodes. You need to be able to read your nomenclature on the components. So 2D is essential as 3D. But this is a 2D system for post-production. That's going to look at objects, presumably in the final assembly and box build area. Can you explain a little bit about how this works?
Yeah, so there are 2 points to this system. One is measurement, high accuracy, high repeatability measurement, and the other one is inspection. So we use a 2D process, which is OMRON core technology again. So we have RGB lighting, which we call MDMC. This is multi-directional, multicolour lighting. The benefit is that we're able to change the angle of the lighting, the RGB light, with a vertical light, and also change the color, the contrast, to really extract the real colour and to find accurately a point to measure. Because part of this is a metrology machine where we can measure point to point less than 10 micron repeatably. In fact, with a 6 micron camera here, we can measure plus or minus 10 micron.
Right, okay. And what about somebody who's looking to maybe measure the Z height of the object?
Yeah, well, we can introduce the laser, OMRON laser, which we are now looking at one particular application, which is after the SMT line. And in fact, it's not to do with SMT. This is another process for a 5G type product, where we're having to measure the thickness and the area of a particular metal. Right. The application is to stack the metal, and in between there is a transparent glue. With OMRON technology, we can find the volume of the transparent glue with our laser and MZNC lighting technology. So we're now expanding the zero defect now from what would be a manually operated metrology system that is still human operated, it is slow and not often repeatable, although accurate, to an automated system that can be in line, that has very fast cycle times.
It's incredible. It's incredible. Well, Kevin, you know, there's a lot happening here. You know, I want to thank you for giving us a walkthrough on your approach to zero defect, and we look forward to catching up in future when you know, we have more time to talk about this in more depth. Thank you.
Lovely. Thank you very much.